We're on page 9 and we're going to prove the double angle and half angle identities using the sum and difference formulas. So we're going to first start off with the assumption that A plus B, the sum of A plus B, is the sum and difference formula that we learned from the other day, sine of A cosine of B plus cosine of A sine of B. Well, we've only looked at examples thus far of A being a distinct value from B. However, what if A and B were the same values? So on the next line, you see in place of A you have theta, in place of B you have theta, and this is where the double angle comes in. Theta plus theta is 2 times theta, so it's double theta. So now if we use the sum and difference formulas from above and substitute in theta for both A and B, this is what happens. We get sine of theta, cosine of theta, plus cosine of theta, sine of theta. Well, we know that multiplication is commutative, so sine of theta times cosine of theta is the same thing as cosine times sine. So that's, if I use a single variable to make it simpler, that's xy times y plus yx, which would yield 2xy, or in this case 2 sine of theta cosine of theta. So if I have sine of theta plus theta, or sine of 2 theta, then that's also equivalent to 2 times sine of theta times cosine of theta. Okay, and so we can write down the double angle formula for sine below, 2 sine of theta cosine of theta. Let's go ahead and hit pause, and if you guys can try the cosine one, copy down the sum formula for cosine of A plus B, and try yourself to see what you would get when you substitute everything in. So hopefully you guys copy down cosine of A cosine of B minus sine of A sine of B, realizing that when you substitute in theta for A and B, you get cosine of theta times cosine of theta minus sine of theta times sine of theta. So if we simplify that, cosine times itself is cosine squared of theta minus sine squared of theta. And so that's my double angle formula for cosine, but there's more than one way to write this expression, because we also know that sine squared plus cosine squared is equal to 1. So remember Pythagorean identity, there's multiple ways of rewriting this equation. So one of the expressions that you can come up with is sine squared of theta is equal to 1 minus cosine squared of theta. And why that becomes important is that now I can go back and substitute in 1 minus cosine squared of theta into that expression for sine squared of theta. And what happens is I get 1 minus that expression. So, sorry, not 1 minus, but cosine. So if I copy down the formula from above, I have cosine squared of theta minus sine squared of theta is this expression here. So that's going to go in where I have the underlined pink part, 1 minus cosine squared of theta. So if you summarize all of that, that's cosine plus cosine is 2 cosine squared of theta minus 1. Go ahead and hit pause, and this time what I'd like you to do is solve it for cosine squared of theta, your Pythagorean identity. Solve this for cosine squared of theta and make the substitution. So cosine squared of theta is equal to 1 minus sine squared of theta, and double check what you get. So hopefully you guys solved for it and you got from the substitution that your another double angle formula for cosine would be 1 minus 2 sine squared of theta. So let me go ahead and highlight all three. These we will copy over to the next page, but one of the first one we came up with was this. Using Pythagorean identity, we came up with this. And then the third one is this one.